Two common applications for our right triangle trig are angle of elevation and depression problems. Now at first glance, the definition here looks kind of scary. An angle of elevation is an angle formed by the line of sight and the horizontal plane. Horizontal just meaning this direction, flat from left to right. So the angle formed by our line of sight when looking up is called an angle of elevation because you are elevating your head in order to look up. In English, that really is about all we need to think about. Are you looking up? Yes, then you have an angle of elevation. If you're looking down, you'll have an angle of depression. We'll get to that one next. But all of our problems that we're going to take a look at right now are going to be elevation problems. So starting off, notice I don't get a picture for any of these examples, so you'll want to draw one. The angle of elevation from a fishing boat to a top of a lighthouse. So we'll go ahead and say we've got our boat down in the water, and then we've got the top of the lighthouse somewhere over here. You don't need to actually draw a little sailboat. You could if you wanted. It's fun. Run away. But we got our boat, our top of the lighthouse, and those 2 points are enough to get us a right triangle. So they gave us the angle of elevation. The angle of elevation from that boat to the lighthouse is 5 degrees. And they told us that the top of the lighthouse is 161 feet above sea level. So they want us to find out how far the boat is away from the lighthouse. So our goal is to find this distance. That's our goal, how far away from the base of that lighthouse there. And they gave us just an angle and a height for the lighthouse. That's actually enough information. That's enough for us to go ahead and find that value for x, the distance between the two. So in order to do that, it's helpful to note that we do have a right triangle, and we want to make sure we label what we have. That 161, that is our opposite side. Note that across from the right angle is our hypotenuse. That leaves the last side to be the adjacent. So I know the opposite, I want the adjacent, that's a tangent problem. So we want the tangent of our angle, which is 5. And tangent is opposite over adjacent. So this is one of the problems where our variable is in the denominator. Most people like to do this as a cross multiply problem. Of course, if you like the shortcut, the switch, feel free to use that shortcut. I'll continue doing these as cross multiply so everybody can see all of the work. So cross multiplying here, x times tangent of 5 degrees is just going to be x times tangent of 5 degrees. On the other side, we have a 1 times 161, which is just 161. And of course, to get x by itself here, now I need to divide both sides by tangent of 5 degrees. And if we divide one side of the equation by tangent of 5, we need to divide the other by tangent of 5. So at this point, what we have is 161 over tangent of 5 degrees. That's something that we could go ahead and throw in our calculator. When we jump over to the calculator, we want to be careful. I had a lot of questions after the first round of videos. Why are my answers wrong? Your calculator is going to default to a unit called radians. Right now, we're talking about degrees. So if you scroll down and highlight the word degree, make sure you hit enter to change the setting. That will make sure that your calculator is in the correct mode. Second quit gets you out of that. And now we're good to go ahead and use our calculator. Keep in mind, alpha F1 brings up your fraction menu, so we can go ahead and type that whole thing in. 161 divided by tangent of 5. And we get 1,840. They don't tell us how to round, so we'll round to the nearest tenth, 0.2. That is our value for x. And And then keep in mind, these application problems are going to have units. In this case, it is feet. So that is how far away our boat is from the lighthouse. So again, it's just a trig problem like the ones we did previously, but now you have to think about what that triangle looks like. What are the different pieces of information here? Let's do another one. 12 here, the angle of elevation. Again, another angle of elevation problems. They all will be for this section. Angle of elevation is 44 degrees. What we're looking at is the bottom of a slide to the top of a slide. And if you think about a slide, yeah, something like that. So our angle of elevation is 44 degrees. 44 is that angle there. The top of the slide sits 16 feet above the ground. So that top of the slide there is also a height, just like it was for the lighthouse problem. But what they want us to find now is different. Now they want us to find the length of the slide. In the last problem, we found this distance, the distance from the boat to the base of the lighthouse. In this problem, though, they want us to find the length of the slide. That's a hypotenuse. The hypotenuse is the length of the slide. Smartboard hates me today. Good enough. So we want to be careful. Not every problem is a tangent problem. So it's helpful to go ahead and label your triangle real quick. 16 is our opposite side. That highlighted part is our hypotenuse because it's across from the right angle. And then the near side is the adjacent here, the leftover. Since we know the opposite, and they want us to find the length of the slide, our hypotenuse, I'm going to use sine. Sine is our opposite over hypotenuse trig ratio. So it's sine of 44 degrees. I know the 16, my opposite. I want to find x, my hypotenuse. So just like last time, again, if you're comfortable with the shortcut, feel free to use the shortcut. I'm going to continue cross multiplying so that I can show all of my work here. In order to go ahead and cross multiply, we're going to have a sine of 44 times x, and also a 16 times 1. So we'll have an x times sine of 44 on the left, and a 16 times 1 on the right. To get x by itself, right now I have x times a number. The opposite of times a number is divide by a number. So dividing both sides by sine of 44, we'll get x by itself. So once again, at the conclusion of a trig problem, you are left with a bunch of calculator work. So we're going to take that 16 divided by sine of 44 and throw that in the calculator. Alpha F1 brings up the fraction menu, 16 in the numerator, sine of 44 in the denominator. That is not a 4. And we wind up with a 23-foot slide. We'll go ahead and continue rounding to the nearest tenth, so that would be 23.0. So in one of these examples, it was a tangent problem. In this one, it's a sine problem. So it's possible to have any trig ratio show up in one of these applications. It's also possible to have inverse trig show up in these problems. So taking a look at one last one, 13 here, we've got a 10-foot ramp. 10-foot ramp used to unload furniture. At one end of that ramp is a truck. So we have a 10-foot ramp used to unload furniture from a truck. If the back of the truck is 3 feet above the ground, that's going to tell us that this part is 3. Find the measure of the angle the ramp makes with the ground. Oh, I did miss one piece of information. The ramp they gave us is 10 feet. That is important. So they gave us the height of the truck, they gave us the length of the ramp. Now our goal is to find the angle. So it's different than the previous two examples because we will need inverse trig for this problem. We still want to take a second and label our triangle. That 3 feet, that's our opposite side. And that 10 feet, that's our hypotenuse. The side that's not marked is our adjacent, so we're not going to use that. They don't ask for it. They don't give us any information about it. You could do Pythagorean theorem to find it if you really wanted to. I don't really want to. So we're going to go ahead and use sine for this problem because I know the opposite. The opposite is 3. And we know the hypotenuse. And sine is opposite over hypotenuse. In this case, what I don't know is the angle, theta. That's our variable. Our goal here is to find that angle. So to get rid of sine, we need to take the inverse sine of both sides. Sine and inverse sine cancel, leaving us with theta equals inverse sine of 3/10. Again, at the end of every trig problem is going to be a bunch of calculator work. So let's head on over. Remember, your inverse trig buttons are right above your regular trig. So right above the sine button, if you hit the second key, will be your inverse sine. It's the same button, you just have to hit that blue second key first. So we're going to have inverse sine of the fraction 3/10. Hit enter and away we go. So we get 17, about 0.5, 17.5 degrees. So there we have it, 3 angle of elevation problems, one using tangent, one using sine, and then in 13 here we actually need an inverse trig in order to find an angle. So it's possible for all the different trig scenarios from the previous couple of days to show up inside of one of these applications. Let's take a look at 3 depression problems. I'll put those in the next video. See you soon.